Tuesday. Can you believe it? Week 10 already. We talked a little bit about cyber defense, and we have a couple options. We haven't verified the ISU, traveled down there. There's the other option is going to participate in the Midwest cybersecurity or cyber defense competition, and that one ends up in Chicago. And the first round is in February. And it ends up in March, like right over spring break. So we kind of have to decide if we want to participate in that one, and that's November 15th. So that's on our radar. The problem we don't have a lot of second-year students this year that would help us prepare. So it'd be good to do one this year so we're better prepared to participate next year. Okay. A couple things we talked about in the classroom. You can log into NIAC Access. It's a router. Cisco's the password right here, and it allows us to communicate with networking equipment. We went over that the first time today, and we'll talk more about that the rest of the term. Network Essentials. We looked at small business network, then we looked at some subnet. Actually did a subnet example today. And we looked at putting workstations on these small networks, the design, and then we configured the workstation. Important. Thursday we have a checkpoint, chapters 1 through 5. The can't overemphasize study. We did a lot of things on learning. If you know students that have been in the IT or other intro to computers classes, we've done a lot of things talking about learning and how important it is to prepare for the test. Not to assume you remember everything just because you did well on the quizzes, but to look through and look at difficult concepts, and then we'll have some time to ask questions Thursday, along with doing some networking things on Thursday too. So this is the setup we did today. The students put a workstation on these 4 networks. They're all different networks, and you can tell by the red. I can re-emphasize that a little bit. This is the network part of the address, and we know that because of the /24. This is a different network, 111, 112, 113, and 114. And I create those. Okay. The default gateways were all a .1. You can see those .1. So it's the same network with that address. And then the switches, I gave them an address of .2, so then I suggested that the workstations, when you put on a workstation, that they would make them 192, 168, then whatever number, I suggested 3, and that they added another one, .4, and so forth. So all the people have connectivity going out, and then we looked at a couple things. So we had connectivity through the firewall out into the internet, and then the traffic came back, maybe I'm using that color, and it got through the firewall because on the way out the firewall created, I'll draw a little tube, like a tunnel to let it back in. It sounds kind of funny, but it does. It remembers where it went. It's going to allow that traffic to come back in. Comes into this network. This router sends it down here. Then this router looks in the routing table to see which interface it's going to send it out of. We're going to look at that again on Thursday. And then when it sent it out, we looked at those MAC addresses. We did an ARP, and we saw it matched up the IP of the workstation. Let me just, let me see here. Let's say we had a workstation here. It matched the IP and the MAC address to that, so it puts the correct MAC address, so when it hits the switch, it goes to the right workstation. So it was a good example. We didn't talk, today we didn't talk about this device does NAT right here, and then the firewall is doing NAT. Whoops, let me back that up there. The firewall is doing NAT to a public address for out here on the internet. And then also, we talked about this part of the network here is the normal network in the room, all the regular PCs, and then this one is coming through part of the DMZ, in which these switches and these devices here are at. Okay? So then I asked them, what is their address out on the internet? And I went to Aaron.net. I don't know which one they went to. And then it gave me this address out on the internet. And then I checked that address, and NIAC has these addresses to use, these public addresses out on the internet. Now, in order to make that efficient here at the college, some of those addresses can be used in the IT area, and some of the addresses in the IT area, and some of the addresses in the main campus. So we have a routing device that decides that. So when a student goes from the IT area out to the internet, when it comes back on campus, that router knows that that IP address belongs to the academic IT area in comparison to the main campus. So how do we do that? Well, the NIAC has this address to start with. Our internet service provider, the ICN, Iowa Communications Network, that address they control, and they gave us that whole address. So we have this whole range here, 256 combinations. We could put 254 addresses on there, because we can do with that whatever we want. So here's what subnetting does. Okay, so we took the address and we said we're going to split it. We're going to have this part represent the different networks, and this part represent the host or interface, usually called host, or in IP6 though referred to the interface. Okay, now there were 8 bits, right? So we got 8 bits, 1, 2, 3, 4, 5, 6, 7, 8 bits. And we divided it here, so we have 5 bits for the host or the interface, and then we have 3 bits for the network. Now those 3 bits can be divided up, you know, all the different combinations. 2 to the third is 8. So we have 8 combinations. So here's the first combination, 3 zeros, then 001, 010, 011, and then 100. So that's 5. Then there would be 3 more. Okay, so we 101, 110, and then 111. That's 8, right? Let me count, make sure I'm right. 1, 2, 3, 4, 5, 6, 7, 8. So we have those 8 combinations. So what I did was I started calculating it. So the first network would be this. That's a 0 because those are all zeros. And then here's the range of addresses. We can start at 1 and go to 30. You can't use 31 because it's the broadcast, and 32 is the next network. So then our next network, the range here, goes from 32 is the network, so 33 is the first address, 62 is the last address. 63 is a broadcast, 64 is the next network. How do we get a 64 here? Well, we got a 1 here, and a 0, and a 0. That's one group of 64 when you look up here. Get it? Yeah, we're going to go over it more as we move along. So then we go from 65 to 94. 95 is the broadcast. 96 is the next network. 96 is 2 1s right here. 32 and 64 is 96. And then we get this range of addresses up through 126. And then we could calculate the rest of these, just write them all out. Then you can decide how you're going to use those networks. Okay? Does that make sense? Yeah. You say, well, it's easy for me to say. All right. We're gonna look at this more. Continue to look at that more. Oh, and then here's an example. We looked up our address here and there. Well, that's it for today.